Hello everyone, my name is Logan. Welcome back to the lecture hall. Today we're going to be doing the fourth lesson of single variable calculus. We're going to be covering section 1.4 Exponential Functions. So what is an exponential function? Well, it is a function in the form f of x is equal to b to the x, where b is a constant. So the graph of it would look like this, where x equals 0, f of x equals 1, and where x equals 1, f of x equals b. And so you can see b to the x is equal to b times b times b x amount of times. So now if you're just to look at the table to get a little better understanding of the graph, you see when x is 0, b to the x is 1. When x is 1, f of x is b, and so on and so forth. When x is 2, b squared, 3, b cubed. So if x is a rational number, and for our purposes it always will be, x can be in the form of p over q, where p and q are integers and q is always greater than 0. So b to the x would look like b to the p over q, which is equal to b to the p in the q root, or it's also equivalent to b to the q root to the power of p. So now if we're going to look at a few of the graphs, we have y equals 1/2 to the x, where it's going to be decreasing, and all exponential functions will hit the y-intercept at 1. So we can see for y to the 1/2 x goes downwards, it hits 1 at x equals 0, and then hits 1/2 at x equals 1. For y equals 1/4 x, we see hits 1 at x equals 0, and hits 1/4 at y equals x equals 1. 10 to the x, same sort of thing, goes up this time because it's not a fraction. Hits at 1 when x equals 0, hits at 10 when x equals 1. For y equals 4 to the x, same sort of thing. X equals 0, y equals 1, and then x equals 1, y equals 4, and then y equals 2 to the x, same thing yet again. When x equals 0, y equals 1. When x equals 1, y equals 2. So now on to a little more about exponential functions. So the rule of thumb is that the b value is in between 0 and 1, then the graph will be decreasing. So we can see that from y equals 1/2 to the x. Since it's between 0 and 1, the function is decreasing from negative infinity to positive infinity. If b is greater than 1, it will increase, which we can see at y equals 10 to the x and y equals 4 to the x. It's increasing from negative infinity to positive infinity. And if y were to equal 1 to the x, it would look like this, because 1 to any power equals 1. Right? Alright, so now we're on to the important part. We're on to the laws of exponents. Alright, so b to the xy is equal to, oops, I made a mistake. I am sorry. It's b to the x plus y, my apologies, is equal to b to the x times b to the y. B to the x minus y is equal to b to the x divided by b to the y. And then b to the x to the y is equal to b to the x times y. So an example of this is b cubed squared. That would equal b to the sixth, right? All right, now the final identity is with two variables, or two constants. You have a, b to the x is equal to a to the x, b to the x, right? So that's pretty simple. So we'll go over some applications when we do the practice problems, but the final thing I want to talk about is the number e, Euler's constant, which it's a seemingly normal number between 2 and 3. It's approximately 2.718, and it was founded by the renowned mathematician Leonhard Euler. This number is special because the tangent line of y equals e to the x at 0, 1 is equal to 1. So we're going to get a lot more into tangent lines in the next few lessons, but I'm going to just draw this out so you can see it and give you a brief little heads up for what's coming. So we have our xy axis, we have 1, and then we're going to need 1, and that's going to be e, and it's just going to go like, sort of like this, right? So this is y equals e to the x. And so this is just a preview because we will go over tangent lines a lot, but pretty much at 0, 1, the tangent line has the slope equal to 1. So let's just say this were a tangent line. Its slope is equal to 1. So its rise over run is equal to 1. So we will go into tangent a lot, as I said, in the next few chapters. I was just trying to show this off, show why E is important, and it's important for a lot of reasons, but this is just one of the reasons. So that's all of the lecture for today. Questions in the description, suggested problems to do in the description, and let's transition to the practice problems. Alright, back onto the questions. Sorry about the light here and here. I'm trying to figure stuff out when filming. So we're going to do problems 1 and 3, but one thing I'd like to cover first is a useful law that I didn't necessarily say. It's a law of exponents. It's kind of a subset of one of the laws, but it's b to the negative x is equal to 1 over b to the x. Now if you remember back, like, 4 minutes ago to the laws of exponents, where it's b to the x minus y is equal to b to the x over b to the y. Well, for b to the negative x is equivalent to b to the 0 minus x, which is equal to b to the 0 over b to the x, which is equal to 1 over b to the x. So that's why b to the negative x is equal to 1 over b to the x. Alright, so that's important. I take note of that. Now on to the questions. Alright, now that we have the law, we can move on to the questions. So this is asking us to use the law of exponents to simplify the expressions. So pretty much what we're trying to do is we're trying to make this into a smallest form of possible, right? So we're trying to just break it down. So the first thing we have to see is, well, man, this would be great if it was a 4. Well, then we can think back to our exponent laws and see, well, 2 squared is 4, so 2 to the negative 8 is equal to, well, since that's 2 squared to the negative 4 right? And then that means 4 to the negative 4 is equal to 2 to the negative 8. So now we move on to this. So we have 4 to the negative 3 and 4 to the negative 4. And then what we want to do is, well, we see, okay, this is negative 3, this is negative 4. Well, we can cross this out, right? Because that's to the negative 3. And then we just get rid of this. Make that to the negative 1. So that's equal to 1 over 4 to the negative 1, which is just equal to 4. Alright, now on to 1b. We have 1 over, so this one is 1 over x to the fourth root 3. So now we're just going to try and get it into the rational form, where it's the p over q form. So this is equal to x, this is equal to x to the negative 4 root 3, right? And then this is equal to x to the negative 4 over 3. So that one's done. That one's not too hard. Now on to 3a. So we're going to, again, want to get it in one form. So what we're going to first do is distribute this 4, right? So this is going to be 2 to the 4. So it's b to the 8 times 2 to the 4, b to the 4. Right? And then we're going to multiply out the 2. That's going to be 16. And then since it's b to the 8 times b to the 4, that's just equal to b to the 8th plus b to the 4. So that's b to the 12th. Right? And now on to 3b. We're going to do something pretty similar as 3a. So now we're just going to do 6 to the 4th. I don't know that off the top of my head. And then that's going to be y to the 12th over 2y to the 5th, right? So then we're going to cross out the 12, we're going to cross out the 5, and do 5 minus 12. That's equal to y to the 7th times 6 to the 4th over 2, which is equal to 36 squared over 2 y to the 7th. I don't know that off the top of my head. I'm sorry. But that's pretty much, that's as good of a form as any. So those are the questions. Those are going to be, those are the questions. The more suggested are going to be in the description. My name was Logan. Thanks for watching and have a great day.